Hi guys! Today I am going to be going over something that I didn't even mention in any of my last videos that I was going to be going over, but I sent out a message to all my students and I said, like, what are some areas that we should be going over? And I sent a list of basically a ton of things that we've gone over through the semester or through the school year, and a lot of people said greatest common factor and least common multiple. And I'm actually really excited to go over these because I hated finding greatest common factor, and I hated finding least common multiple. It was like my least favorite thing to do. It was my least favorite thing to teach. And then I learned the ladder method. And the ladder method has made finding the greatest common factor so much easier for me. So now I actually look forward to seeing problems like this because this is something that I know how to do. So I'm going to show you guys this method, which you guys, if you're doing Swan Math, you've seen. If you're doing Engage New York, you have not seen. But either way, doesn't matter what curriculum you're using, you can use this method to find the greatest common factor and the least common multiple of every pair of numbers that you get. Okay, before I even go into examples of how to find greatest common factor and least common multiple, I want to kind of remind us what those two terms even mean. So a greatest common factor, a factor of a number, is basically any number that can fit inside of it. So it can be divided evenly into that number. So if I'm looking at, let's say, the number 6, factors are numbers that fit inside 6 can be divided evenly into 6. So every whole number, 1 is a factor of. 1 is always a factor, okay? And now I'm going to sit there and I'm just going to go through and basically see what factors of 6 are. 1 is a factor. 2. Can 2 fit into 6? Well, 6 divided by 2 is 3. That's a whole number, yes. So 2 fits. Okay, 3. 6 divided by 3 is 2. That's a whole number. Okay, 4. Well, 6 divided by 4, I don't know. That's going to have a decimal. That is not a factor, because if my answer is going to have a decimal, that's not going to be a factor of it. 5, 6 divided by 5, that's going to have a decimal. That's not right. 6 is the number itself, right? If I said 6 divided by 6, I'd get 1. So that's a factor as well. Every number has 1 and the number itself as their factor. If they only have those two things as a factor, it's called a prime number. If they have more than those two numbers as a factor, then it is not a prime number. I should know the term. I should know the term right now, but I don't. When we pause, I'll come back with it. Okay, so I'm going to give another number. So let's say 4. Well, I just told you 1 can go into every number, every whole number, right? 2, can 2 go into 4? Well, yeah, 4 divided by 2 is 2. So 2 can 3, 4 divided by 3, I don't know, that's going to be a decimal. And then 4 can go into itself, right? So if I'm looking at 6 and 4, the factors of 6 are 1, 2, 3, and 6. The factors of 4 are 1, 2, and 4. Now I'm going to be looking for what factors do they have in common. Well, they both have 1, yeah. They both have 2, yeah. No, that one doesn't have 3. That one doesn't have 6. A number cannot have a factor that is larger than itself. So if you get to the number, so once I got to 4, I just stopped there because a bigger number isn't going to fit evenly inside 4, right? When it's a factor, it has to be smaller than the number itself. So now I know that 1 and 2 are the only common factors that they have. And when I'm asking for greatest common factor, I'm just asking for which one of those numbers is bigger. Well, 2 is bigger than 1, so my greatest common factor of 6 and 4 would be 2. That's the biggest number that can be divided evenly into both 6 and 4. And the reason that we want to know that is because when we get to things like reducing fractions, say, and you see a fraction that says 4 sixths, it's really helpful to know the greatest common factor, because if you know the greatest common factor, then you know exactly what to divide by in order to simplify it. So I just found out that the greatest common factor of 4 and 6 is 2. So now I can divide the top, or the numerator, and my denominator by 2 to get the value of that fraction. What that means is the most simplified form. So whenever you see like a question and it says reduce or simplify, the greatest common factor is really the best way to ensure that you're getting the most simplified version. So in order to find the simplified version of 4 6, I know, well, 4 divided by 2 is 2, 6 divided by 2 is 3. So 4 sixths simplified is 2/3. Now that was our greatest common factor, but we still have to go over what the least common multiple means. When I'm thinking about least common multiple, I'm thinking about it in terms of skip counting. So what that means is if I were to skip count by both numbers, what would be the first number that they'd have in common? I think that's going to make more sense if I just write it out. So I'm going to skip count by 6, and then I'm going to skip count by 4. I typically stop at like 10, but sometimes you are going to need to keep going. Unless you use my version, which we're going to do in the next example, and then you won't have to do that. But for this example, we're just going to go to 10. So I didn't give myself enough room. We might not be going to 10. We might be going to 5. All right, so 6, 12, 18, 24, 30, 36, 42. I'm out of room, so I'm going to stop there. Now I'm going to go by 4s. So we have 4, 8, 12, 16, 20, 24, 28. This is like what you'd see on your multiplication chart. This is literally just me adding 4 each time. These are the multiples of 4. Now when I'm asking for least common multiple, I'm asking which of those numbers do they have in common? And of those numbers, which one's the smallest? So this one's kind of easier than greatest common factor in the sense that once you find your answer, you can just stop. You don't have to keep going. So I would just start with one line and then I see, okay, 6 down here, nope. Is 12 down here? Yup. That's going to be my smallest answer. So 12. That means that my least common multiple is 12. Now, I'm going to show you how to do this using the ladder method. We're going to use a different example first. Okay, as promised, I looked up that term. If it's not a prime number, it's a composite number. So prime number means there's only 2 factors, aka 1 in the number itself. A composite number is any number with more than 2 factors. Okay, remember that, even though I didn't. Okay, so I'm going to now show you the ladder method. So you guys can see the ladder method on the same numbers so they can prove to you that the ladder method works. And obviously I'm going to be teaching this out, so it might not take that much less time, but once you get proficient in the ladder method should take significantly less time than the method that we just used. Okay, so I'm going to use the same 2 numbers. I'm going to use 6 and 4. Sorry if you can hear Chomper snoring in the background. He's right under my whiteboard, and he just wants attention. Okay, so the first thing that I'm going to do is I'm going to draw what I like to think of as an upside down division symbol, or division box. The reason that I like to think about it that way is because this is going to involve some division. 1, 2, I made the mistake of calling it an L, and that threw me off in the long run. Don't call it an L. You'll see why, and I'll go over why in a second, but that is not an L. Division box, upside down, or just a ladder, or just remember it. I don't know. Whatever works for you. Okay, and so now I'm going to look at these 2 numbers, and I'm going to think of any number that I know that goes into it. It does not have to be the greatest common factor. It just has to be a factor. So it can be any number besides 1. 1's not that helpful, I'm going to be honest with you. That can go into both 6 and 4. 1 goes into every number, but 1's not that helpful. 2, can 2 go into 6? Yeah. Can 2 go into 4? Yeah. So I'm going to put 2 there. And like I said, that's like my upside down division box. So now I'm going to divide. So what's 6 divided by 2? 3. What's 4 divided by 2? 2. And now I'm going to look at my next row and I'm going to think, okay, is there any number that can go into both 3 and 2? Well, 3 has 1 and 3. 2 has 1 and 2. If I used 1, it's just going to end up looking the same. I don't even have to divide by 1 because if I divide by 1, everything stays the same, right? So this is as far as I can go here. In order to find my greatest common factor, what I do is I would multiply all the numbers on the side together. In this problem, it's pretty easy because there's only 1 number on the side, so I don't actually have to do any multiplying. You'll see an example where you're doing multiplying because usually you will have to do multiplication, but this problem is an easier example. So my greatest common factor is just 2. Say we had like a 2 and then the next row we had like a 4, you would multiply those together, so it'd be like 2 times 4. But this example, only number is 2. Now, I told you guys that you could use the same strategy and get your greatest common factor and least common multiple. I do not have to do any extra math in this little part right here to get my least common multiple. And I mean, I do have to do extra math, but I have all the stuff I need in order to find least common multiple, is what I'm trying to say here. So in order to find my least common multiple, I draw my L. I told you guys, couldn't call it an L earlier, and this is why. My L is going to be multiplying the numbers on the side with the numbers on the bottom, okay? So in order to find my least common multiple, I always remember it as my L, right? It looks like a little, it's kind of funky looking, but that's an L. That green thing, that's an L. It'll get better as we go along. Just trust me. This is kind of a bad example, but I just wanted to prove to you guys that it works. And now in order to find least common multiple, you just multiply all the numbers in the L together. So I have 2 times 3 times 2. And we did 2 times 3 is 6 times 2 is 12. And we had just found that in our last example, right? In the last way of showing you, the last strategy, I guess would be a better way of putting it. We knew that the greatest common factor was 2, and we knew that the least common multiple, geez, I'm sorry, I'm tripping over my words here, was 12, and this is just basically proof that this method works. Also, the reason I use this method is because for me, it's a heck of a lot easier to remember which one's greatest common factor and which one's least common multiple, because least common multiple starts with L and it looks like an L, right? That's how I remember it personally. But I'm going to go on to another example using different numbers, which will require more steps. So you guys are going to have a better idea of why it's called the ladder method, and why I call it an L, because that, I'm going to admit it, that doesn't look, I mean, I guess it's the same shape, but that's not the best L I've ever seen in my life. Okay, now I am going to use a slightly larger number here. So I have 36 and 4. And my first step is writing the numbers, and then I'm going to write my ladder, my upside down division box, whatever you want to call it. Besides L, you're not calling it that. And I'm going to look for any number that I know goes into both 4 and 36. I personally like to just go through and see what works. Okay, so 1, 2. Okay, can 2 go into 36? Yeah, because that's an even number. Can 2 go into 4? Yeah, that's an even number. Okay, so I'm just going to start off with a 2. And we'll work our way down from there. So my first step is not my first step. I'm on step 3. I don't even know who I was kidding with that first step thing. My next step is going to be dividing both of these numbers by 2. So 36 divided by 2. I want you to pause and I want you to solve that by yourself. All right, welcome back. 36 divided by 2, you should have gotten 18. 4 divided by 2 is 2. Now I'm going to look at my next slide. I'm going to see, is there any number that goes into both 18 and 2? Well, duh, 1, right? But 2, can 2? Okay, well, 18 divided by 2, that's a whole number, right? That works. 2 divided by 2, that works. So now I'm going to add another ring to my ladder. I think that's what that's called. Is that what it's called? Let's ask Siri. Ladder rings?
Sorry, I didn't catch that. Try.
That's not important. That's not important. Stay focused. I'm going to just look at any other number now that goes into this next line. So we just said it. We were just there. I'm sorry. I'm all over the place. We just said 2 goes into both. Okay, so now 18 divided by 2, it's the same step. I'm just dividing again. 18 divided by 2 is 9. 2 divided by 2 is 1. Okay, now I'm going to look at this line and say, is there any number that can go into both 1 and 9? Well, remember, a factor cannot be bigger than the number itself. So the only factor we could really look at would be 1. Dividing by 1 does not help us. It's going to give us the exact same number. So I can just stop here. Whenever you have a 1, you're done. Okay? Whenever you have a 1 like in your bottom row, you're finished, because 1 can't be divided into any whole number. It's the smallest whole positive integer that there is. So that means that I now have all of the information I need to solve greatest common factor and least common multiple. So greatest common factor, remember, I'm just looking at the numbers on the side here. So greatest common factor, you multiply the numbers on the side together. So 2 times 2 equals 4, which means our greatest common factor of 36 and 4 is 4. Now we're going to go on to our least common multiple, which would be like our L. So least common multiple, we're drawing an L. See, now as we're getting a bigger ladder, that looks more like an L. Still a little funky, but it looks more like an L at this point. And now in order to find least common multiple, I'm going to multiply all of these together. So I have 2 times 2 times 9 times 1. That is hard for you to see down here because of the glare from my light. But I want you to pause. You can just look at them right here. And multiply those together so that you can find the least common multiple. All right, welcome back. Okay, so you should have done 2 times 2 times 9 times 1. 2 times 2 is 4, times 9 is 36, times 1 is still 36. So my least common multiple is 36. Now, obviously we're still new at this, but at this point I'm hoping that you're seeing that this is slightly less time consuming and, in my opinion, personally, a little easier than the original method for finding least common multiple and greatest common factor. The reason I really like it is because all of the information is just in one little, is in one strategy. So I don't have to skip count on one and then I list factors on the other, because then I think that that's why people get confused in terms of, okay, which one's least common factor and which one's least common multiple and which one's greatest common factor. When we do it like this, especially because we have that clear L there, I think it makes it a lot easier for us to differentiate between the two vocabulary terms, and then we can just get the answer for both, which a lot of times problems will ask for both, using one strategy. Okay, we're going to do a few more examples. All right, for our next example, we're going to be using the numbers 40 and 24. Step 1, we are writing our upside down division box. And then we are going to look at 40 and 24, and we're going to think what numbers go into those two numbers. So you can start with 1 and then work your way up. Or if there's a number that you just know goes into it, like you look at those two numbers and you know, like, oh, 4 goes into both of them, you can start there. It does not matter what you start with as long as it is a factor. Obviously, if you're using something that's not right, that's going to give you the wrong answer. But it doesn't matter which factor you start with. You'll end up with the same answer as long as you're doing all of the steps. So I'm going to keep going with that same theme of starting with 1. Okay, 1, obviously 2 now. Well, 2 can go into 40 and 2 can go into 24. So I'm going to use 2. And now I'm going to divide. So 40 divided by 2 is 20. 24 divided by 2 is 12. And of course, if you need to work these out, do so. Pause me, work it out. Okay, I'm just trying not to make this video 2 hours long. I'm trying to save you guys. And now I'm going to see, okay, is there a number that goes into both 20 and 12? Okay, well, 1, obviously, yes. 2 can go into 20, 2 can go into 12. So we know we're not done yet. So we have to add the next ring of our ladder. And let's go with 2. Okay, if you knew a different number, remember, that's okay. You can use that other number. 20 divided by 2 is 10. I'm just going through that whole process again. Remember, I'm still dividing. Is 10. 12 divided by 2 is 6. Are you good? Chomper is making so much noise, so I apologize if you can hear that in the back. I hope you can't, because that would be distracting. Okay, so now I have 10 and 6, and I'm going to look, are there any numbers that go into both 10 and 6? Okay, well, 1, 2. 2 can go into 10. 2 can go into 6. Go 2 again. All right, 10 divided by 2 is 5. 6 divided by 2 is 3. Okay, now let's look at 5 and 3. Can 1? Yes, 1 can, but that's not helpful. 2 can't go into either of those numbers. 3 can't go into 5. And 4 is bigger than one of my numbers, which means I can't have a factor that's larger than one of my numbers. So that means that I'm done even looking. I mean, you could go to 5 if you want, but we're done. Either way, there's nothing else that can go into these numbers besides 1. If it's helpful for you to write this out and do a 1, absolutely you can. You're going to get the exact same numbers. You're going to get the same answer in the long run. Doesn't really matter, okay? But in order to find our greatest common factor, it's the same thing that we've been doing. You're just going to multiply the numbers together that are on this side. So we're multiplying all these together. Remember, if I added 1, 1 does not change my value, so that was okay. And I'm going to multiply 2 times 2 times 2 times 1. So 2 times 2 is 4, times 2 is 8, times 1 is still 8. So my greatest common factor of 40 and 24 is 8. Now I can also find the least common multiple with this method as well, and I'm going to draw my L. So I'm having all of my side numbers, and now I'm including the bottom numbers too in order to find my least common multiple. So my least common multiple, you can still read that, is 2 times 2 times 2, 2 times 2 times 1 times 5 times 3. A lot more, but we got this. 2 times 2, 4, times 2, 8, times 1, still 8, times 5, 40, times 3, pause that and solve it if you don't know it. 40 times 3, you should have gotten 120. So using this method, we found that the greatest common factor is 8, and our least common multiple is 120. I'm going to do one more example, and I'm going to try and make it a harder one. If you're ready, this is going to be your challenge problem. All right, I promised you a challenge problem, and here it is. So if you want to pause this before I even start working on it and try and find the greatest common factor and least common multiple on your own, can you stop? Do so. Now would be a good time to pause, work it out. If you want to. If not, stick with me. We got this together. All right, welcome back if you paused, and still hi if you never left. Okay, so I'm going to look at 14 and 88, and I'm going to think about any number that can go into both numbers. Okay, so how I would start this, you guys know by now. 1, duh. 2, okay. And remember, any number that's an even number, 2 can go in it. So that means any number that ends with 0, 2, 4, 6, 8, that's all of them, is an even number, which means it's divisible by 2. Well, this ends with a 4. I'm going to write them up here in case. Any number that ends in those numbers is even, meaning it can be divided by 2. Well, this ends in a 4, so that's even. That ends in an 8, so that's even, which means that 2 can go into both of those numbers. Okay, well, 14 divided by 2, we know that is 7. And 88 divided by 2, we may not know that, but you can pause and solve it. Hi, welcome back. 88 divided by 2, you should have gotten 44. All right, and now I'm going to see if there's any number that can go into both 7 and 44. All right, well, 1, yes. 2 can't go into 7. Hang on. If I had $1 for every time he interrupted me trying to record a video, this is video number 11, I'd have $11. That's enough to at least get in and out twice. Okay. As I was saying, I'm going to go through it. I'm going to say, okay, 1, yes, but 1's not helpful. 2 can't go into 7. Okay, 3 can't go into 7. 4 can't go into 7. 5 can't go into 7. 6 can't go into 7. 7 can't go into 44. That's not a factor of 44. And any number that's bigger than 7 is obviously not going to be a factor of 7 because it's too big. So I'm done trying to find my factors. This is the most simplified form. So what that means is that I already have all of the information for my greatest common factor and my least common multiple. And I told you guys it was going to be a challenge one because you might not have just known that 2 went into 88. And also because of our least common multiple, we'll get it. Okay, so our greatest common factor, there's no multiplying to do. We have it. Our greatest common factor is 2. Now our least common multiple, oh, it's down here. Sorry. We are multiplying both the side numbers and the bottom numbers together. So now I have to do 2 times 7 times 44. Now, if you had not worked this out, I want you to pause it and I want you to work this out now. All right, welcome back. So 2 times 7 is 14. 14 times 44. I don't know that off the top of my head, so I am going to work this out. 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. Next line, I'm adding my 0. 4 times 4, 16. 4 times 1 is 4 plus 1 is 5. So my answer for my least common multiple should be 616. And there you go.
that was a much bigger number. That's why I considered that my challenge problem. So if you got that, give yourself a pat on the back. If you stuck with me till right now, give yourself a pat on the back because you tried. You killed it. You did great.
All right, for practice on these problems, I am putting this up on the whiteboard so that you can pause it, screenshot it, do whatever you need to do. And I want you guys to solve these problems. I will put the answers to these problems in the description box, but don't look at them until after you've tried to solve them. As always, if you guys have questions, message me, comment, anything. You guys know I'm here to help. I'm sure there was something else I was supposed to say, but I forgot. I hope you guys are staying safe. I will see you guys soon. Bye.